Okay, let's do a little bit of reliability practice. So whenever we use a scale, we want to be able to provide the internal consistency of that scale. And I mentioned this on Blackboard that we tend to report either Cronbach's alpha or we report McDonald's omega. So there's a little bit of a paradigm shift happening right now in research. For as long as I can remember, we've always reported Cronbach's alpha, which is a lower bound for the internal consistency. And we've gotten to the point where we want to do a little better than that. And there's one of two ways we can do a little bit better. One is to report a confidence interval around Cronbach's alpha. In a couple weeks, I will go into more of what is a confidence interval and how to interpret them. But basically, in a nutshell, it's that we're building a fence around the number that we calculate for alpha. And what we're saying is that with some level of confidence, maybe 90 or 95% confidence, we can say that the true alpha is in this range of numbers. Or we report something called McDonald's omega, which is going to be a little bit truer to the actual internal consistency of the scale. So let's just practice on a couple of scales that I've pulled. And this will also show you or introduce you to JASP and how to get data in our software. So I've got the software pulled up here, and this is what it will look like when you open the software on your computer. And we want to get our data in. And my data file is over here. It's called Alpha Practice. And when you click on File, all right, and we want to open from our computer. And you'll notice that we can look on our desktop or in our documents. And so I'm going to look on my desktop because that's where I have the file. All right, and you are not letting me, aha, you know why? Because it doesn't allow us to import Excel files. This is my bad, and this is wonderful practice for you guys, that we actually have to import comma delineated files or .csv. So here, and this is good practice for you on how to go from an Excel file to a .csv. All right, so here is our Excel file, and I'm going to go into File, Save As. All right, and notice that the default here is an Excel workbook, but I'm going to change that to an MS-DOS comma separated file. All right, so I click on MS-DOS comma separated, which is the .csv, and I say Save. All right, and don't worry about that message. It just doesn't like saving as CSVs. And so now we can go back to, and we see that I have my alpha practice.csv on my desktop. So I'm going to go back to my desktop, and there is the file that we want to open. So we're going to open this file. All right, and notice that the column names become get imported correctly as column names. And so I have this success through outdoor rec, all right, is one of the scales that I'm interested in. And then another scale, and you'll see this, it's actually coded or colored rather in the Excel file. We have no job through good jobs is another scale, all right. And we'll play with this data off and on throughout the semester, but let's go through calculating some internal consistencies. All right, so we go into Descriptives, Reliability Analysis. All right, and so the scale that we want to use, we'll just do, I tell you what, let's actually start with something a little bit shorter than that first big one. So we've got rarely pay, dropout, bad grades, school's a waste of time, and scholarships. All right, so I'm going to, this is all, what these variables are is they're supposed to load on a construct of school value. And what I'm using here is a survey that has been given over the past 5 years to about 7,000 rural students in the state of South Carolina. And they are aged anywhere from 6th grade through 12th grade. All right, and that's one of the fun things in this class is because I am a data person over in the Child Development Research Center, we're going to get to play with lots of fun data that may be of interest to you. All right, so anyway, we've got these 5 items that we are hoping load on something called school value, and so I moved them over. And notice here we've got options of what we can calculate, and what we would like to calculate is McDonald's omega, Cronbach's alpha. Let's also calculate alpha if the item is dropped. Okay, and then we're going to go under advanced options, and this is where we can get a confidence interval around alpha. All right, so let's just take a look over here and make sure that you can interpret these numbers. Okay, so what do all these numbers mean? All right, so remember I said Cronbach's alpha is a lower bound, okay? That means it's always going to be smaller than McDonald's omega. All right, so we see here that the internal consistency is around 0.38, looking at Cronbach's alpha, and rather than citing that number exactly in our methods section for the scale, we would say with 95% confidence, we believe that Cronbach's alpha is between 0.35 and we can round there to 40. All right, McDonald's omega is a little bit higher at 0.46. And then I also wanted to show you what happens if you check looking at the alpha if an item is dropped. What this shows you is, do you have an item that is really throwing off your internal consistency? Meaning, does alpha substantially go up if we get rid of an item? All right, and notice, okay, so here's alpha, right, 0.376. So alpha goes down if we get rid of that one, alpha's going down, but then look here at scholarships. Alpha jumps up almost 2 points if we get rid of scholarships. So that's saying that that item, scholarships, is really not good for our internal consistency. All right, so I'm going to go back up here and I'm going to drop that item. And now we can see that our reliability has substantially gone up. Alpha is up to 0.526 and our McDonald's omega is up to 0.572. All right. Now, probably the million-dollar question that you're asking yourself is, well, what is a good reliability, right? What do we want that alpha to be? And the answer is 0.7. 0.7 is our cutoff value. If the scale is above 0.7, it is considered reliable or having internal consistency. If it is below 0.7, you're going to have a hard time getting that analysis by reviewers as being a reliable scale. All right, so let's take a look at, let's do one more. So obviously here this school value scale is not very good. And we wouldn't want to use it. Let's take a look at something that might be a little bit better. So let's take a look at these items here. All right. So from SNS, BCK down to let me tell you what these 5 items measure. These 5 items are meant to measure rural attachment or rural identity, so the degree to which the student is attached to their rural environment. All right, and so we put these 3 in, and notice that our alpha is 0.877. We've got our confidence interval that we can interpret, and then we've got our McDonald's omega at 0.878. Nothing really increases substantially if we get rid of an item. And so what we say here is that because we are above 0.7, this scale on rural identity has internal consistency or is considered highly reliable. and we would again write either this 95% confidence interval for alpha, or we would report McDonald's omega. Okay. What I will do is I will put this Excel spreadsheet and the CSV in Blackboard, and you can practice on the two other scales in here. They are color-coded in the Excel spreadsheet, so you would know which ones to pull if you want to practice looking at reliability.